Okay. All right. So we're going to work on finishing these problems from page 480. Okay. So the directions for this section said, find the sum of each infinite geometric series. So infinite means it goes on forever.
Forever.
Defined by the given sequence. If the geometric series diverges, writes no finite sum. So remember we talked about converging and diverging the other day. Converging means it comes together to a single point. Diverging means it's going out forever. So if it's going out forever and diverging, then we can actually get a sum for that because it's going on to infinity. So we have our formula that we use for the infinite geometric series up here on the board. The sum is equal to the first term divided by 1 minus r. Everybody remembers r stands for the common what?
Ratio.
Common ratio. Okay, so it gives us the actual terms in the sequence. So since it gives us the terms in the sequence, we have to find the common ratio ourselves. So to find the common ratio, remember you take the second term, which was 1, divided by the first term. So can I actually divide 1 by 2? You'll still get a fraction, so it's still going to be the 1/2, right?
Yeah.
Good with that, yes?
Yeah.
Okay. So our r is going to be 1/2, second term divided by first term. So now all we have to do is plug them in. Our first term is obviously the 2, because that's the first term that it gave us in the sequence. So we just plug them into this formula. Now, you don't know what n is, okay? Because on the others, we had a number for n because it was a finite geometric series. We were counting, we were doing the sum of the first 6 terms, or the first 4 terms, or the first 10 terms. This is infinite, so we can't do that. So we just still have s of n is equal to our first term 2 over 1 minus r. So 1 minus half. So then we just simplify that. 1 minus a half is a half. And then to finish dividing here, remember your big fraction bar means dividing. We talked about this on one of the problems yesterday. To divide by a fraction, we actually end up doing what?
Multiplying.
Multiply. We do copy, change, flip. So this becomes 2 times
2 over 1.
2 times 2 over 1, or just 2. So 2 times 2 is
4.
So we were able to get a sum. So that means instead of diverging, it what? Converges.
Converges.
Because we were able to get an answer. So that's it. That's number 17. See, that wasn't that hard. The infinite geometric sums are the easier ones, okay? Because the formula is a lot smaller. This is number 19, okay? We were supposed to do, I forgot which numbers I had written down for y'all to do. Did y'all write them down? I'll go look in a minute. Anyway, this is number 19. We'll do number 19 and number 21, and then I'll go see which one it was that I want you to do on your own. So on number 19, my first term is 4. To find my common ratio, I take 5 divided by 4. I'm not going to really divide that because it's still going to be a fraction. So I might as well leave it as the improper fraction. So my ratio is 5/4. So I'm ready to plug it into my formula. Sum is equal to my first term over 1 minus 5 to the 4th. So what did we do first? 1 minus 5/4, right?
Yeah.
What's that going to give you? Huh? I go with you.
I don't know.
Negative 1/4. Okay. So remember, this is 4 fraction bar means divide. So 4 divided by -1/4. But then to do division, we copy, change, flip this fraction over. So this flipped over will be just -4/1 or -4. So then 4 times -4 is -16. So my sum for number 19 was -16. Everybody got that one? Pretty easy.
Yeah.
Wait a minute, what am I doing? Wait a minute, that's not right. We're not supposed to have a negative one. Hang on a second. Ah, that's why. Okay, I knew we weren't supposed to have a negative sum. See, this is why you need to pay attention to your notes. Okay, on your notes, it says an infinite geometric series is said to converge if its sum gradually approaches a specific number or if the partial sums grow larger and larger without restraint. The series is said to diverge if the absolute value of R, so the absolute value of my common ratio, is greater than or equal to 1, the series diverges. So is this bigger than 1?
Yes.
Yes, that's greater than or equal to 1, so it diverges. So we weren't supposed to do that. It has no finite sum. I knew we weren't supposed to get a negative on that. See, you all let me do it. All right. It's my fault. All right. Sorry. I didn't have time to look back over everything before like I normally do, so I apologize. Number 21. Your first one is 11. So A1 is equal to 11. My R is 5/11. Now, is this one less than 1? 5/11?
Yeah.
Less than 1. So we can do this one. So we should have checked that first on each one, but I didn't. So that was my fault. Don't be mad at me later. So we're going to plug it in. So I have sum of n is equal to my first term, which was 11, over 1 minus 5/11. Okay, so 1 minus 5/11 is 6/11. There you go. And so then I have 11 divided by 6/11. So remember what we talked about. If you have a division, you do copy, change, flip. So 11 times 11/6. So what do I get when I multiply that?
$20 and 1/6.
Wait, did I write that down right? No. What did I do? Okay, what did you say? 121/6.
Yeah.
Okay, this is actually number 23. I'm on a roll today. I'll tell you what. I'm all over the place. That was actually number 23 because I was looking at my book and I said that doesn't look like 21 because it wasn't 21. All right, hang on a second. I'm going to go look and see what the other problem was that we were supposed to do. Okay. All right, so you all try number 18. Number 18 is the one I wanted you all to do. So number 18, if I can write it right, 9, 1, 1/9, 181, dot, dot, dot. Okay? So you all try number 18, and then we'll check that. And again, I apologize for messing up so much already.
I sent the link to your mom in my schoolwork. But type this in, DJ. Type it in at the bottom of the search bar, not even in the search bar, in the web browser. Type in pro prop.
Everybody done?
Put a forward slash.
Nobody done? Nobody done? It's not hard. All right. So first thing, this is A1. R is going to be 1/9. Is that greater than 1 or less than 1? Less than 1. So that means we can do it, right? So I'm going to have A1 is 9 over 1 minus 1/9. So 1 minus 1/9.
8/9.
8/9. Because 1/9 with 8/9 makes 9/9, which is the whole thing. So I have 9 divided by 8/9. So then I have 9 times 9 over 8. And then you multiply straight across, and you get 81/8. Okay? Pretty good?
Yeah.
Okay. All right. So what we're going to spend the rest of the time doing today is working on some review problems. On that next thing, you see down there at the bottom where it says review of sequences and series on page 480. We had already done part of those either last week or the beginning of this week. I don't know. All my days are running together anymore. But we already did them before your last quiz. And so now we're getting ready for the quiz over section 10.4 and 10.5, geometric sequences and series. So we're rolling over. And we're going to work on some problems on page 481. Okay, we may or may not do all these. I just want to make sure we at least hit one of every type to cover the problem so you have examples to look at when you are taking your quiz. Okay? All right, so we're starting with 17 and 18. So on 17 and 18, our directions say, determine the next term of the geometric sequence. Okay, I'm going to do number 17 because that's definitely more like what you have on your quiz. Okay, so on number 17, it says, I lost it, 6, 18, 54, 162, and we're trying to find the next one in the sequence. Now remember, this is a geometric sequence. So since it's a geometric sequence, do we add to get the next term or multiply to get the next term?
Multiply.
We multiply. Okay, so we have to find out what we multiply by. What we multiply by is called our common ratio. So to find our common ratio, you take the second term divided by the first term. So 18 divided by 6 is 3. So that means to keep finding each term, they're multiplying by 3. So I'm going to take this and multiply it by 3. So 162 times 3.
486.
Huh?
486.
Yep. So that's your next term. Okay? So that part's pretty easy, right? Find the next term in the sequence. So we should be good with that. Okay? Like I said, we won't worry about the others yet. We'll go back. I just want to make sure I at least hit one of each type before make sure we have time. All right. Here, we'll go ahead and do number 20 as well. It's the same thing, but it's got fractions just to make sure you know how to do one with the fraction. I got 5, 5/6, 5/36, 5/216, and I'm looking for the next one. So we always start by finding our common ratio. So I take the second term divided by the first term. Remember, we've talked about this division already. So it's 5/6 divided by 5. So that's going to be 5/6 times this flipped over, which is 1/5. So the 5s are going to cancel. My common ratio is going to be 1/6. So that means I'm going to multiply this times 1/6. Now that shouldn't surprise you that you're multiplying by 1 on the top, because you'll notice all of them had a numerator of 5. So it's going to be 5 over something, but then you take 216 times 6.
$1,296.
So your answer is 5 over 1296. Okay, so that's finding the next term. So that part you should be good with for the quiz. Then number 21 and 22, for those, it says find the formula for the nth term in each sequence. Use this formula to find the indicated term of the sequence. So this is like that first formula that we did in 10-4 the other day. So 10-4, we had our basic geometric formula. Okay, our basic formula is AN equals A1R to the N minus 1. Okay, does that look familiar? Okay, so that's what we are going to be using for these next two problems. So I just put the formula real big so you have it. We'll do the problems over here to the side so you can still see the formula. So let's look at 21.
21.
21 says the 7th term of 2, 8, 32, 128, Okay, so my N is 7 because I'm looking for the 7th term. My A1 is 2 because that's the first term in my sequence. And then I also need to know my R to plug it into the formula. To find the R, remember we've already done it several times today. You take second term divided by first term. So it's going to be 4. So after we found our N, our A1, and our R, we're ready to plug into this big formula for our geometric sequence. Okay, so to find my 7th term, it is equal to my first term, 2, times my radius, my ratio, which was 4, to the N, which was 7, minus 1 power. Now, order of operations tells us we have to do the subtraction and the exponent first, and then we have to take care of the exponent, and then we do the multiplication. So we're going to start up here. 7 minus 1 is 6. And then I've got 4 to the 6th power. So 4 times 4 times 4 times 4 times 4 times 4. So remember, are you all going to want to make sure you have a calculator when you're doing these quizzes?
Yeah.
Yes, you are. So you've got 4 to the 6th power. And then I'm gonna, okay, so that's 4,096. And then I've got to multiply that by the 2 that was in front.
8,192.
So the sum of the first 7 terms in that sequence is 8,192. Okay, let's do another one of those because I know you have like 2 of those on the quiz. I'm trying to make sure you have examples for everything on the quiz. That's my goal. Okay, so make sure you have these down. That way you can look at them when you're doing the quiz. If you have your notes with all your formulas and you have these, you should be good. Okay, number 22, it says the 8th term of 530, 180, 1,000. Oh, I don't know why I put 2 commas. 1,080, dot, dot, dot. Okay, so my first term is A1 is 5. I gotta find my R and I gotta find my N. Now my N, it told me I'm looking for the 8th term in the sequence. So I'm looking for the 8th term, so I put an 8 for my N. To find my R, I take my second divided by my first. So 30 divided by 5 is 6. So now I have my numbers I can plug into my formula. Okay, so I have my 8th term in the sequence is going to be equal to my first term times my common ratio to the 8 minus 1 power. And then we work it out. Okay, so hopefully everybody knows 8 minus 1 is 7. So you're going to take 6 to the 7th power and get a big number for that. And then we multiply that by the 5, and you get an even bigger number for that. Remember, with the geometric ones, we talked about this again the past couple of days. You're going to have a lot larger numbers in your answers because you are multiplying every time to get the next term in the sequence instead of just adding. So that's why we're getting such big numbers. So by the time you get to just the 8th term, it's already going to be in the millions. Okay, so it's going to be humongous if you kept going past that. Okay, so everybody good with that formula?
Yeah.
All right, so the next part, for 25 and 26, it says determine whether each geometric sequence is converging or diverging. So number 25 says AN is equal to 2/5 to the n power over 4. And I'm going ahead and write down number 26 too. And it's 8, 64, 512, 4,096, dot, dot, dot. Okay, so I was just getting those written up there. So remember, we already talked about it a little bit. Converging means it goes together to one number. Diverging means they're going separate. It's spreading out apart. Okay? So when we're looking at number 25, we kind of have to use, we kind of have to use what we did in the other. We kind of separate it a little bit and think about this. Remember, whatever's being raised to your power is your R. Okay? Just like in our formula over here, the R was, well, you can look at it right here, the R was raised to the power. So what's being raised to our power up here is our R. So on this one, our R is what? 2/5, right?
Yeah.
So remember, we always compare that with 1. So is that less than 1?
Yes.
Yes. So since it's less than 1, does it converge or diverge?
Converge.
Converge. So this is converging. And on the quiz, you have them, I think they're like little drop-down boxes. Like it has the two, converging or diverging, and so you just pick which one works for that sequence. Okay? Now on this one, on 26, you're doing the same concept. And I think most of them you actually have on the quiz are like this. Okay, where it actually gives you the sequence. So you have to find the R first. But we've done that like almost every single problem today. So everybody should be able to do that. R is always second divided by first. Second divided by first. So 64 divided by 8 is 8. Now, obviously, I hope you all know that, is that less than 1?
No.
No. That is not less than no. So it cannot converge. It is
Diverging.
diverging. Okay? If it's less than 1, it's not converging. It is diverging. Okay? What's the next problem we have? That was 25, 26. So 27 and 28. Those directions say, find the sum of the indicated number of terms for each geometric sequence. So 27 says first 8 terms of an equal to 3 to the 7 n minus 1. And then 28 says, I'm going to move y'all over in just a minute. I'm just writing my things up here. An equals 12 times 4 to the n minus 1. All right, so let me roll y'all over. Okay, so we're supposed to find the sum of the indicated number of terms. Okay, so for these, we're using a different formula. Okay, our formula that we use for 27 and 28 is one that we had yesterday. Okay. That's the one that we're going to be using today. Okay. This is our formula. Okay. So for number 27, in the number of terms it said we were looking for the sum of was the first 8 terms. So n was 8. My A1, you all, this is written, it should look very familiar. It should look like how we started number 21 and 22, that formula. So my A1 is the number in front of the parentheses, the 3, and my R is the number that's being raised to this power, the 7. So these are my numbers, but I'm plugging them into this formula because we're finding the sum of those first 8 terms. Okay, so my sum of the first 8 terms is equal to A1, which was 3, times 1 minus R to the n power over 1 minus R. And these are like what we were doing yesterday. So you're going to take 7 to the 8th power, and you get a big number for that. 5. And you've got 1 minus that, so you got a big number for that. And then on the bottom, 1 minus 7 is negative 6. So then you work that out. A big number times the 3 divided by the negative 6. And if you think you got the right answer, let me know. It should be in the millions if you did it correctly.
Jeez.
Huh? What'd you get?
2,882,400.
Oh, I need to sneeze. Okay. What? 2,882?
Yeah.
Okay.
400.
Yeah. I was going to say, I don't remember 6, so there. So see, isn't that fun?
Mhm.
That's fun. You know it's fun. All right, is 28 going to be the same way? Yes?
Yeah.
Okay. And on number 28, it said you're looking for the sum of the first 10 terms. A1 is 12 and R is 4. So these are the 3 numbers we're going to plug into that formula. So my sum of the first 10 terms is equal to 12 times 1 minus 4 to the 10th power all over 1 minus 4. And you would simplify that. Everybody see where we're at? Right here. And you'll end up with an answer in the millions. If we set it up right. Okay, I'm done.
So am I.
Yeah, if you're using a handy dandy scientific calculator, you can actually type it all in, all the top in at once, and then divide it by what you got on the bottom and get it. So it doesn't take that long. Everybody good with that one? 4,194,300.
Yeah.
All right. And then the last ones that I had on there, 31, 32, and 35. So 31 and 32 are like what we just finished up on yesterday's today. So those are the ones where we use this formula. Okay, where we use that formula. Okay, so when we're doing those, remember the first thing is we have to make sure whether or not R is less than or equal to 1. Okay, so that's our first goal. So looking at number 31. 31, you have 200, 160, 128, blah, blah, blah. Okay, so first thing I gotta do is I gotta find my R. So, okay, I just got like 20 emails at once. Okay, I gotta find my R. So I have R over is equal to second over first. So when you're doing this, you gotta simplify it. 16 over 20 is gonna end up simplifying to
4 over 5.
4/5. Okay, is that less than 1?
Yes.
Less than 1. So yay, that means we can do it. Okay, so we're ready to plug it in. So I'm plugging into this formula right here, my infinite sum. So S of n is equal to my A1, 200, over 1 minus my R, 4/5. So 1, a whole thing, so that would be like 5/5, minus 4/5 would leave me with
1/5.
1/5. And remember, with the big division, you end up doing copy, change, flip. So you have 200 times, I flip this fraction over, so it would be 200 times 5, so I get
1,000.
1,000 is my sum for number 31. Pretty easy? Yes? All right. Number 32, same formula. Number 32, same formula. The sequence that they gave us was 10, 100, 1,000, blah, blah, blah. Okay? R is equal to second divided by first. 100 divided by 10 is 10. Is that less than 1?
No.
No. So that means it's diverging. So it has no finite sum. It's diverging, so it has no finite sum. Okay?
Yeah.
Ready for that? We're good with that? Y'all ready for the last problem? So, last problem's the favorite one. It's a word problem.
Oh,
Did you just whine?
no.
Mm-hmm. It sure sounded like it.
Nah.
I know Yaneli loves word problems. She does.
I don't think so.
I think so.
No.
Yeah, okay. It's fine. All right, so number 35 says Ralph receives a yearly bonus of $1,000 and invests the money every year in an account that pays 5% compounded annually. Okay, so his amount that is being deposited, deposited is 1,000. His rate is 5%, but remember you always combine it with 100 because he's already got that in there too, plus the extra 5% interest. So that ends up being 1.05 when you change it to a decimal. And it said he's leaving it in there for N amount of time, 5 years. So remember for these, we had a more complicated, where did I set Charles' notes? Okay, we had a more complicated formula for that. I had to find it because I want to make sure I didn't leave anything out. Is this it? No. No. But it was the AN equals, I'll find it here eventually. And the AN equals your amount deposited times the rate, and then 1 minus the rate to the N over 1 minus the rate. That's our formula we used for that. Okay? So, the amount deposited was 1,000. So, after 5 years, you're going to have $1,000 times 1.05 our rate times 1 minus 1.05 to the 5th power over 1 minus 1.05. So that's what we have to try to simplify in our little calculators to see how much money they're going to end up with. So everybody should be typing it in.
I got a negative number.
For the top or the whole thing?
The whole thing.
Well,
I
on
can do it.
the bottom, aren't you also going to have a negative?
Yep.
So a negative divided by a negative makes it what?
Positive.
Positive.
Okay.
Okay, so we get a positive number now.
Yeah.
Now remember, money only has how many decimal places?
2.
2. So we got to round it off where there's only 2 decimal places. Aurelie, did you get an answer?
Miss, I keep on getting error.
So that means you're not typing it in right. What are you typing it in on? Do you have a regular calculator or on your computer?
Like a phone calculator, but like on this website type thing.
Oh. Usually on something like that, you'll have to take that, you'll put it apart individually and then multiply it all together.
Okay, hold up. Let me try that.
Okay. Did anybody else other than Micah get an answer? I know Yaneli did because word problems are her favorite. Right? Nobody else? Crickets?
Hold up, miss. I almost got the answer.
Yeah, no, I totally did it wrong.
All right, what'd you get?
$14. No, but the first time I got $291.
Oh my Lord. Okay, let's go backwards. Okay, 1.05 to the 5th power. That's this part right here. Is 1.276 blah, 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 blah. Okay, but I got 1 minus that. So I'm gonna, so basically since I've got 1 minus that, I know it's gonna take the 1 off and just give me what I got with the negative on there, right?
Miss,
What?
is it 5,801 and 91 cents?
Oh, very good. Yes.
Okay.
Look, look, yay. Okay, so when you get this, you end up with the negative 0.276, blah, 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 whatever. Whatever that is, you're gonna times that by 1.05 and by 1,000. And so you end up with this big negative 290 something on the top, divided by negative 0.05 on the bottom, and then that's how you end up with 5,801.91. Okay, so you all have to try to figure out, there's a lot of little like free calculator apps that you can find, and a lot of them, like the one I have on my phone, when I have it turned this way, it's like a regular little calculator. But when I turn it this way, it's the scientific calculator. So it has your little exponents and stuff buttons on there. Okay, but it's just a free little calculator app. So if you don't have a scientific calculator, there are still some that you can find that are free that you can download. You just have to ignore, they all have ads on them, but you know, that's the price of free. But it'll work if you don't have a calculator you can use. Okay, but all of this covers stuff that's on the quiz. Okay, so for the quiz, ProProfs has been having some issues today. So I'm going to go back in and change where you have between now and tomorrow afternoon. But the thing is, that means you have between now and tomorrow afternoon to take it. No excuses, no extra time. Yaneli passed out, she's gone. All right, so, okay, you've got to make sure that you have it done by tomorrow afternoon. I'm going to put it 6 p.m. because afternoon ends at 6 p.m. We tried to discuss that the other day. 6 p.m. starts evening. Okay, it is quiz number 34. Quiz 34 is the one that you're supposed to try to take. If you have these examples with you that we just did when you do it, everybody should at least pass it. Okay? So, if you have not already done so, I've had a couple people send me things. If you have the capability of taking pictures of your work and emailing it to me through My School Works, then you need to do so. You also need to get in the habit of during the week, so Monday through Friday, you need to kind of get in the habit of logging into My School Works at least 2 or 3 times a day, like maybe morning, lunchtime, and evening, to see if you have any messages, emails, things about quizzes coming up, whatever, okay? So try to get in the habit of logging in there a couple of times a day. Now on the weekend, you don't have to log in 3 times a day, but I would still check it like Sunday night every week, because by then all of us have usually posted our lesson plans for the next week. So you gotta kind of get an idea of what's coming up for the week ahead. Okay? So everybody knows you have what to take? I'm listening. I want to hear everybody tell me.
Quiz
A quiz.
Quiz what?
34.
Quiz 34. Okay? So, and you have between now and when?
Tomorrow, 6
Tomorrow
p.m.
at
Tomorrow at 6
time.
p.m. And the only reason I'm giving you, because originally I had it till like 8 o'clock tonight, but I know they've had some issues today, and so in case something happens and it kind of gets hung up again, you have a chance to still go in there and take it tomorrow. Okay? So that's the only reason I'm giving it till tomorrow, just because where they've had some problems today. Okay, so everybody's good with that? Everybody let Markeith know, since he didn't log in today, about the quiz. All right. Anybody has contact information for him, please remind him. And I will see you all not tomorrow. You don't have to log in tomorrow. I'll see you on Tuesday. So you got an extra long weekend. All right. Everybody ready? Yay. Have a good weekend. Happy Easter. You can't get Easter baskets because, you know, we don't have them. Nobody can go shopping for Easter baskets.